Hey everybody, you ready to learn some long division? Let's do it! Alright, long division. We're going to divide x squared minus 3x plus 5 divided by x minus 2. This is the same example that I did in class at the beginning of class on today's Thursday, so on Friday I did this one in class. So you might not need this example. This lesson has a total of 4 examples, and each one's a little bit different, has like a different surprise ending. So you might want to watch all 4 examples so that you don't get caught like thinking, oh, that's weird. Alright, so we set up these long division problems the same way that we set up a normal long division problem. I personally like to make the little house thing. And inside the house goes the numerator, x squared minus 3x plus 5. And on the denominator goes outside the house, x minus 2. So for the rest of this problem, when we do the long division, we really only look at this x and this x squared. I think x times what gives me x squared? So x times what gives me x squared? Or another way to think about it is just x squared divided by x. Either way, no matter how you think about it, the answer is x. So that x goes up here. Then we distribute. X times x minus 2 is x squared minus 2x. Then this is long division, so what comes next? Subtraction. So we subtract. Be careful with the positives and the negatives. X squared minus x squared, so the x squareds are gone, but these x's, negative 3x minus negative 2x is really negative 3x plus 2x. So it's negative x, and then you drop down the plus 5, and then you ask yourself, x times what is negative x? Or you could think about it as negative x divided by x is what? And no matter how you work it, it's a negative 1. So the next thing I put up here is minus 1. And then we distribute. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. And then after we distribute, we subtract. Be careful with the negatives. Negative x minus negative x. X's are gone. 5 minus 2 is 3. Then, you know you're done at this point because you can't fill in these blanks. X times what is 3? Well, that doesn't really make any sense. Or 3 divided by x is what? Nothing's canceling out or anything. That means that we're done, and 3 is your remainder. And with that remainder, you always go plus the remainder divided by your x minus 2. And that's how you worked out number 1. So we have the answer with your remainder. Okay, like I said, I have 4 examples. Each one's a little bit different. Number 2, let's say I had x squared plus 3x minus 18 divided by x plus 6. This one's got a catch. Not a catch. Can you see? This one's a little interesting. Can you see what's going on? Can you? Can you? Well, no worries if you don't, because the long division will work it out for us. X squared plus 3x minus 18. So x times what is x squared? X times x is x squared. So I put an x here. Then we multiply. X times x plus 6 is x squared plus 6x. Then we subtract. The x squareds cancel out. 3x minus 6x is negative 3x. Drop down the negative 18. Then ask yourself, x times what is negative 3x? X times what is negative 3x? And that answer is negative 3. So minus 3. Distribute. Negative 3 times x plus 6 is negative 3x minus 18. Interesting. Interesting. What happens when you subtract 2 things that are exactly the same? You get 0. So this one has no remainder. So the answer is exactly x minus 3. Now, remember at the beginning of the problem when I was trying to bully, you've been like, hey, you see what's going on with this one? Do you? Do you? Well, what you may have noticed is that this is factorable. This is factorable into x plus 6 times x minus 3. That numerator is. The denominator is x plus 6. Then what happens? What? The x plus 6's cancel out, and what you're left with is exactly x minus 3. So, long story short, if you ever look at this and you notice that this is factorable in any way, maybe it's an x cubed and you could factor it by grouping, who knows? But if it's factorable, you can factor it and cancel stuff out without doing all the long division. Save yourself some time. Example number 3. It's what we're trying to be. Okay, this one, it's a little bit different. Number 4. X squared minus 9 all over x plus 4. If I think about that last problem, like, oh, I noticed that this numerator is factorable. Even if I tried to factor it, x plus 3x minus 3 over x plus 4, in this case, nothing cancels out. So there's no real point in doing this because nothing canceled out. In this problem, factoring would work out because something canceled out. So factoring is only useful if stuff actually cancels out. If it doesn't, you go through the long division. Now, this is where people make a lot of mistakes because in this, like if you go back to this problem, number 2, we had an x squared, an x to the 1, and an x to the 0. So kind of each exponent of x was represented. Whereas here, I have an x squared, but I don't have an x. But it needs to be there as a placeholder. So I go x squared plus 0x minus 9. And 0 times x is just 0, so you're still mathematically correct. Now, run through the same process. I'm going to go a little faster now. X times what is x squared? That's x. Then we distribute. X squared plus 4x. Then we subtract. X squareds cancel out. 0x minus 4x is negative 4x. Drop down the negative 9. X times what is negative 4x? That's minus 4. Distribute. Negative 4 times x plus 4 is negative 4x minus 16. Subtract. Be careful here. The 4x's cancel out, but negative 9 minus negative 16, that's like saying negative 9 plus 16, 7. 7, and then at this point, x times nothing gives me 7, so that's going to be our remainder. So it's plus 7 over this x plus 4. And that is my final answer. And I called that example 4, but you all know it wasn't example 4. It was example 3. I have one more example for you. It's called example 4. Well, on my notes, for some reason, it's called example 5, but I'm going to call it example 4. I need to go get a piece of paper. Hold on. I found a piece of paper, and I'm back. Okay, this one, it's going to be written a little bit differently. Number 4, instead of being like, having the division bar, it's going to be written out long like this. 5x to the 5 minus 6x to the 4 plus 3x squared minus x plus 1 divided by x squared minus 7. This one's meant to be the challenging problem. If you can do this long division problem, you're going to be able to do any long division problem that I throw at you. Outside the house, x squared plus, you need to, just like the inside of the division house, all of the x exponents need to be represented. This one's missing the x term, so it's x squared plus 0x minus 7. Inside the house is going to go all of this stuff, and notice one of the exponents is missing, x cubed is missing. So when I write this out, I'm going to leave the, I'm going to put a 0x cubed in there. So 5x to the 5 minus 6x to the 4 plus 0x cubed plus 3x squared minus x plus 1. All right, here we go. Roll up the sleeves. x squared. X squared times what? I'm going to write this down one more time. X squared times what equals 5x squared? 5x to the 5, excuse me. Or another way to think about it is what is 5x to the 5th divided by x squared? And no matter which way you think about this, the answer is 5x cubed. So up here goes a 5x cubed. Then just like, I know this problem looks more complicated, but at the end of the day, you run through it the exact same way that you run through all of them. Next, you distribute. This becomes 5x to the 5 plus 0, 5 times 0 is 0, x to the 4 minus 35x cubed. Then you subtract. One clue that you're doing things right, this thing on this step should always cancel out. And if it's not canceling out, something's wrong. 0 minus negative 35x cubed is positive 35x cubed. And negative 6x to the 4 minus 0x to the 4 is negative 6x to the 4. And then drop down the next thing to 3x squared. Okay, x squared times what is negative 6x to the 4? And that would be minus 6x squared. Distribute. This becomes negative 6x to the 4 plus 0x cubed plus 42x squared. Then you subtract. Notice that these are exactly the same, so you probably are doing it right. 3 minus 42 is negative 39x squared. The cubes are positive 35x cubed. And then you drop down the next thing, the x. X squared goes into 35x cubed, 35x times, because 35x times x squared is 35x cubed. 35x times 0x is 0x squared, and 35x times negative 7. Oh, I know 35 times 7. No, I don't. Yes, I do. 70, 210, 245. 245, I think. 35 times 7. Elliot, 245. What? So minus 245x, subtract, x cubes go away. The x squareds, you have a 0 there, so it's just negative 39. Oh, I'm really embarrassed. I've run out of space. Negative 39x squared, and then negative x plus 245x is so plus 244x. Numbers are getting big, but that happens in these. All right, next. X squared goes into negative 39x squared, negative 39 times. This is going to be our last step, and we know that because we've gotten to a point that the exponent's the same, so we got just a plain old constant here. That means that unless there's a remainder of 0 right here, the next thing in here is going to be the remainder. Elliot forgot to drop down the plus 1. Because there's 3 terms here, I want to make sure there's 3 terms there. Multiply by negative 39. I get negative 39x squared plus 0x. 39 times 7, 273, so plus 273. But because this is long division, we subtract. And this problem ends up being the x squareds go away. 244x minus 272. And at this point, x squared times what gives you 24x? Nothing clean, so we're done. So our final answer is all this stuff. So 5x cubed minus 6x squared plus 35x minus 39, then the remainder, so plus this stuff, 244x minus 272, all divided by the stuff we divided, x squared minus 7. And like I said, If you can do this problem flawlessly, you're going to be able to do any long division I would ever throw at you. And that's all I have to show you today, everybody. That's long division. I hope you're having a great Friday or a great Thursday, or if you're watching it on the weekend, I hope you're having a great weekend. Bye-bye.